Welcome back to ReddyControls YouTube channel. In today's video, we continue our Mastering PLC Programming Industrial Automation series with part 2, where we focus on creating PLC file, tasks, programs and subroutines for mapping inputs and outputs as well as for logic of the conveyor belt program. As you can see here on the screen, this is I'll be using Ignition for presenting the HMI, and on the right side you see the finished PLC program for conveyor belt application we talked about in the previous video. We'll be using a COMPACT LOGIX PLC here with a firmware revision 36.011. We'll guide you through each step in offline mode, ensuring you have a solid fundamentals for automation projects. If you're passionate about automation and control systems, hit the subscribe button to stay updated with our latest content. Don't forget to like, share and leave questions or comments below. Let's get started with PLC programming skills and take your skills to the next level. So what you see here is a completely developed application of the program. As we indicated in the last video, we had a layout of the machine we talked about and some of the I/O mapping we discussed last time. To refresh, we have a conveyor belt, and then we have photoelectric sensors which is detecting the box at each conveyor zone. So we went ahead and mapped them here for each one. So if you look at the conveyor run command, we used an output. I have a COMPACT LOGIX embedded I/O card in which I'm using some of the outputs for this. So we'll go through this whole process and let's get started. So you can see here is the program, but this is a fully developed one. Let's go ahead and create a new one. So we will hit File, New, and in here the new project window comes in, and we select our PLC by selecting COMPACT LOGIX 5370, and our PLC is 1769 L24ER QB1B. So we will QB1B and we'll give a name of the project. Name of the project, we call it belt conveyor belt, and file name should start with a conveyor belt and underscore conveyor belt, and we just put today's date for now. And we could select where it's created. Right now it's getting created in the projects folder, which is fine. We hit next and we can select the firmware revision of what we want. I have 34, 35 and 36 installed. We'll just select 36. No protection. You could write description, conveyor belt program, and you could also say developed by. Any useful description that would be good practice to go ahead and leave it here in the project and hit finish. Now what it's going to do is it's going to create a new project file for us. And if you see the project file, it created the controller with the name of the project conveyor belt with the date, and it went ahead and created a main task, and this symbol indicates this is a continuous task. So there are two types of tasks. If you look at properties of the task, we can create two types of tasks: a continuous, periodic or event-based task. Three types. A continuous task runs repeatedly and only pauses to allow high priority tasks to execute, making it suitable for processes that require constant monitoring and control. On the other hand, the periodic periodic task runs at a specific interval that we provide, allowing for more predictable timing and resource allocation. For this project, to keep it simple, we will continue with a continuous task. Say okay. Now once we have the main task, we need to create the main task came with the main program already, and if we want, we can change the main program. We could call it as conveyor main, say apply, okay. And in there, it already created a main program called main routine. We could change that, or we could just reuse the existing main. And typically main routine is the routine where you call other routines using a jump to subroutine command. So for now we'll keep the name as main, but if you look at one thing we want to show, if we go to properties in the configuration, you need to have an assigned main routine. If you don't select that and hit apply, so now the program doesn't know what to do. So we have to go ahead and create a main routine, and you could create your own and call it main, but for us it already creates, and there are parameters for this. If you want to pass any parameters, that we'll discuss in future videos. We go ahead and hit apply. So now all we did was created one main task in which you have, so if you select, this is a good window to see. So if you click on the main task, it tells you the properties of the main task. It's a continuous main task, and then when you select a scheduled program called Conveyor main, in there you have a main routine called main, and this is where we will call the jump to subroutines. So before we call the jump to subroutines, we'll go ahead and create two routines. So all we have to do is click here, add new routine, and we select a name for it. I like to use numbers. There is different best practices, but this is what I have decided, and I will be using a _10_IO mapping, or we call it input mapping routine. We'll go ahead and create, and this routine is where all the puts are mapped from internal. Okay. Go ahead and say okay. Then we'll go ahead and create one more routine called actual logic. So this routine, okay, and both of them are in the main conveyor main, and we say okay. So now we created two subroutines, and now we need to call them using a JSR. So we go here, make this big. So we go ahead and insert JSR, which is part of the program control, jump to subroutine, say okay. And then by default it creates this inbound input parameter and return parameter. We can remove them later, but for now we need to call the input mapping routine, and then all these input parameters you could right click, move instruction parameters, right click, move instruction parameter, and remove return parameter, move instruction parameter. We'll talk about passing parameters in a later advanced videos. And now we can Control C. We could just copy that routine, come to the next line and hit Control V, and we go ahead and now call 20, which is our logic. Okay, so that's all we did. All we did was created two subroutines and we called them. Now we need to go ahead and open the input mapping and start mapping our inputs and outputs based on what we initially said in the previous file, where we talked about this one. So we already know what our inputs are on the field and what tags we need to create. So we'll just follow this one and start creating a mapping routine to map the elements we need. So to make it this, we'll just make this small again, put them side by side so we can see it. So now the first thing we want to do is go ahead and tell what we are trying to do in this one. So we'll hit edit run comment and say this route is used to map inputs to tags. And we could put the date also when this was developed, and we could say 13th July 2024, and who is the author. We could say ReddyControls. So this is a good practice. That way we tell the maintenance technician or a overview of what this routine does, right? So our aim is to create programs which are more readable and helps the maintenance, so we can reduce the downtime. So we'll go ahead and map all the inputs. So we know we are using these inputs, all of this. So we'll go ahead and just to keep it, we could just hit insert do a NOP, no operation on that one. That way this rung is always there. No operation means this rung does not do anything, but we just create that to as a placeholder for the rung comment. So now we go ahead and insert new by clicking and dropping it. Now we created a new rung. In this one we will go ahead and insert we need to look for, go ahead and do it in order. So we want to map a start push button. So we know on the field it's on the local 1, input data 0, so we can browse through, gives us all the local 1 cards. These are configuration. I have both inputs and output. Here we are looking for input, so we extend that, and then in the data we are looking dot 0. So that's my local chassis 1 or local rack. It's called local because it's local to the PLC. It sits right beside the PLC. It's not a remote connection, and it's on slot 1, and it's an input, and it's the 0.0 on it. And we want to map that to something called a start push button. So we go ahead and type start. And one thing we're going to show you is I cannot start a tag with 1, because all the tags need to be following a IEC standard, IEC 61131 standard, and part of that standard is the tags cannot start with a number. So we'll go ahead and try it. We'll just create number 1 start PB, right? And we try to create new tag by hitting right click, new tag, and we'll go ahead and create 1, and it will say fail to create new tag, tag name invalid, because based on the IEC 61131 standard, your tag names cannot start with a 1. Okay, so we'll remove that one. But now what we'll try is we'll try to put a gap between both of them, so it doesn't even let you do that. Oh, that's good. So as long as it doesn't start with a 1, we are good, and it cannot start with a special symbol. It doesn't let us type in a special symbol either. So we'll go ahead and create a tag. The tag name is start underscore PB, and we say, and we always use description. We'll say equal to 1 when the push button is pressed, equal to 0 push button is not. And we'll keep it a base tag. We don't use any alias, but for now keep it a base tag, and data type is bool. We'll go ahead and create. So this tag is nothing but now we wired the green button, the green tag which you see in the video, the green push button, we wired it to put 1.0, and now we created a memory tag that we will use this in the program all through. Rather than typing local 1 input data 0, we'll keep using start push button. Okay, so you could add a comment here, but for now we'll just leave it like that. And now the next, and we'll go ahead and keep mapping the others. We'll go ahead and do, you could either copy paste it if that's what you want. You could Control C it, copy the rung, and Control V. And now we want to map input 2, which is here, input 2. We map it to a stop push button. Let's say stop push button, and we'll go ahead and create new, and we know it is equal to 1 when not pressed, because I'm using a normally close contact on back of the stop push button, not pressed, and equal to 0 when pressed. So we go ahead and create that. So we mapped 2 of them, and we need to map the remaining inputs. So the next one we completed 0, 2, and now we need to complete 5, 6, 7. So we'll go ahead and Control C this one, copy rung, Control V, and we need to do the next is, and we said 5 is wait OK. So we'll go ahead and see what is the tag we used, wait OK. So we'll go ahead and map this to wait, call it wait underscore OK. So all we are doing is, in our assumptions, we said whenever the weigh scale reads good weight, that weight intolerance, it will give us a signal called wait. Okay, and we wired it to that input 1.5, and now we are creating an internal wait. So we'll say equal to 1 when it is okay, it is 0 when wait is not. Go ahead and create that. And next thing we want to do is map the remaining of the inputs. Remaining inputs are 6, 7 and 8. So to make it easier, I will go ahead and Control C, Control C, Control V, Control V. So we do have a 6. 6 is mapped to box present at wayscale. 6 is box present at operator station. So we'll call it 6, and we'll create a tag, a new tag called box present operator station. Okay, so we'll go ahead and do new, and we say equal to 1 and box is red. So that's how you map the inputs. To save time, I will go ahead and open the other program and copy paste. We'll go ahead and hit file, save projects. We'll go ahead and since I've already mapped the tags to save time for the video, I'm going to open the program which was already developed. I'll copy paste those, the remaining of the mapping, and explain. And the important point is the fundamentals is we always want to describe what 1 and 0 means on that. This would help us avoid going and looking into the drawing. Is this a normally open or normally closed contact that's been wired? So it's always best practice to put as much detail as you can in the program, which will help the people coming behind you to look at the logic. So same thing here, we went ahead. So now we'll open the IO mapping. This is how we did. We'll just, I think we already created, we'll go ahead and do from 6 and see how we mapped 6, 7 and 8. 6 is mapped to the box at operator station, 7 is mapped to way station, box present at way station, 8 is to box at the devoter station, 9 is box at devoter 2, 10 is box present at the good conveyor. For photo I6, we kind of will use a signal. So that would be here for photo I6, we will just use a toggle signal. And we also have for future, in this project we don't have a safety relay, but most of the machines on the floor have a safety relay or some kind of a safety controller. From that we get a input signal saying like, hey, your safety circuit is okay. So I went ahead and simulated it right here, safety relays and safety is okay. And for diverter 1 and 2, since these are on pneumatic cylinders, we wanted to have some kind of a feedback when the cylinder extends. So I'm simulating a feedback. Whenever the cylinder gets an extend command, we wait half a 500 milliseconds and get a diverter 1 extended, and we also get a same thing when diverter 2 is extended. After 500 milliseconds we get diverter 2 extended. So we'll go ahead and copy paste all this into the logic. We'll go ahead and Control V. Okay. So since this is a new program, none of the tags are defined, so it's expected to have these errors. So we had to go back and hit create new. I won't waste time typing all the comments because I already have in the other one. This is just purely showing you how to develop it. So we'll go ahead and create. Go ahead and create. All these are booleans, so we'll go ahead and create new, create new, create new, and create, and we'll go ahead and new, create. This is a simulation tag, so we'll go ahead and create that one too. Safety relay is a simulation tag. We right click, hit new, and say create, and safety is okay. We go ahead and safety is okay, create. So as I'm creating them, the X is disappearing. That means the rung is all good. So we'll go ahead and create new extend good parts, and we'll go ahead and create the new timer, create, and we go ahead and create this extended. I'm just showing you the process of how to create new tags. Okay, so that's it. So we went ahead and created input mapping. Now we'll try to download this and do a quick IO check to make sure everything is working as we thought it should. Okay, so to download, you go in and find out who active. My target PLC IP address is 1.10. We select that, and once you select this, if you're on the right controller, you will get this download, go online, upload, download. We'll go ahead and use download and download the program into the PLC. It will give you, hey, you want to download, everything will stop, danger unexpected motion, some devices may be independent configuration, verify all the devices are working. So we go ahead and hit download. So we are taking the connected controller is a good thing to check it's the same IP address which we want. It already had a program, my previous program called conveyor_belt, but now we are downloading conveyor_belt with today's date program, and we hit download. It's going through here, checking all for errors. There is no errors. Finalizing downloads. After downloading is done, it will ask, do you want to go into run mode, remote run mode? Yes. Now the program is running inside the PLC, and we will go ahead and do a quick IO check. We are checking for all the IO is okay, there are no errors in the PLC, so we just want to do a quick IO check, right? So in the main routine, we're already calling for input mapping, so it will go into the input mapping. Now we will go ahead and check if start push button is working. So we'll go ahead and press the start push button, which is the green one. We got a 1, so whenever we have 0 input, we getting start button. So the start button is work. Now we check for the button 3, which is the stop button, which is Y to data 2. We push it, it goes slow. Okay, it's a normally closed contact, so when I'm not pressing it, when it's off the shelf from the box and you wire it 24 DC, it will give out 24 DC out. Okay, and then third one is input data phi. Input data phi is our selector switch. Input data phi is our wait OK signal, which is our selector switch 1 on the trainer. So I will press selector switch 1 into position. I got input phi on, so we are right here. I'll try it again. Off, on, and we have wait OK signal. Wait OK. Okay. Put 6 is our selector switch 2 on the roller. You could see here. We will go ahead and switch that off. You could see the box present at operator station is low. Now we on, off, on, and off. It's very important to go ahead and make sure all your inputs and outputs are mapped correctly. Local data phi, that's wait OK signal. Wait OK is wired to selector switch 1, which is this guy. You could see wait is OK. I think when I copy pasted it, we created 2 of them called wait OK. We'll go ahead and delete one of them, delete this wrong. And box present at operator 6 is selector switch is 2. That's working. That's selector switch 2. That's good. And then we have box at diverter 1 is 8. Box present at way station is 7. Box present at diverter is 8. And then the last switch would be for 9 is box present at diverter 2. 10 is box present at goods conveyor. At good conveyor. Photo I6 is just a user toggle, so we'll just toggle that. That should give safety is okay. Safety relays would be a toggle bit that would give safety okay. So that's how you do put mapping and check all your inputs are wired properly. So overall what we did until now is we created a program, and we created a continuous task and created a program in which we have 2 subroutines called input mapping and logic. We mapped in the main routine using JSRs. We added 2 jumped subroutines and called them, and inside the input mapping we went ahead and mapped everything. So that's how you do mapping of your inputs. This concludes our part 2, which is part 2 of the video, which includes just the input mapping, and in next video we'll start developing the logic routine. Thank you. If you found this video helpful, please hit the like button, subscribe, and leave your questions or comments below. Thank you.